Now consider one program sum of two complex numbers. A small demo on how we use complex numbers. Why we are interested? We are interested in because it has two parts. In general, we are interested in group of collection of elements, right? Group or collection of elements. If you consider a complex number, how it will be? Complex number has two parts. One is real part, another one is imaginary part. So this is our motto, that collection of these are group of elements under single name, right? We know that the real part could be integer or float, or imaginary part could be integer or float. For completion of the definition, I am taking real part which is floating real part, and imaginary part I am taking as a imaginary, because structures support different data types, right? So if you take C1, I mean complex number C1, though it seems like a single unit, okay, it has two parts actually. The first part is real part, second part is what? Imaginary part, okay. Meaning we have clear structures that if my variable name is C1, this C1 should support both parts, which is not generally possible. Therefore, we have to create a new data type. That new data type should has two parts. Two parts are of what? One is real part, another one is imaginary part. Okay. So real part, I am interested in taking the float, as well as imaginary part I am interested to take the integer. So definition is completed. Now I want to provide some name to these, as these are complex numbers. Therefore I am renaming that this structure as a complex. Therefore I am writing like this. The name of the data structure is complex, and this definition is nothing but a structure. Therefore struct complex, semicolon. So here definition part is completed. Very simple. What are the what these are called as? These are nothing but what? Members. What are the members? Real and imaginary are members of a structure, a complex structure. Okay. So this is completion of a definition of a complex data type, right? So data type is created, but doesn't mean that memory is created. Memory will be created only when variables are declared. So in this, I am interested in taking the variables as C1, C2, C3. Now how to do this? C1 is a variable which should be of what type? Just now we declared. Complex itself is a data type. Same way, I am taking one more variable called C2. C2 is a variable which is of what type? Complex type. C3 is a variable which is of what type? Complex type. So this complex is user defined, right? Meaning we just created, and therefore I have to put keyword struct. Of course here also. Struct complex keyword. How to read this? C1 is a variable which is of a complex type, which is a structure. So now see, to provide the input, I have to provide in this part as well as in this part, right? Same way here also. Now tell me, C3 also has same structure, right? Whatever the structure of C1, C2, C3 is also of a same structure, because all these are of what type? Complex type. Whenever this is declared, automatically members, a space of members will be created. So first member is real member, second member is an imaginary member. Now see, what is the result? Result is nothing but sum of these two numbers. Now tell me, what is 4.7? 4.7 is a real number, real part of whom? C1s. Therefore, I am writing here C1, okay, part is what? Real part. Same way, I want to take 5. 5 is what? 5 is of course real, whose value it is? Variable C2. So if I add these two, then the result will be what? I want to store this result in which? Real part. Whose real part? C3, isn't it? This is nothing but what? C3 result. This is nothing but what? C3 dot result. The same way, if I want to calculate the value, what is the sum of these two values? What is position? This is imaginary part of C1. Okay, C1 dot imaginary part, IMG. Memory is nothing but IMG. Same way, C2 dot imaginary, and the result will be stored in which position? This name is imaginary. Whose part? C3's part. The result will be in C3. Okay, just take this demo program. So we are interested in what? We are interested in a definition of complex, right? So complex should support two data members. One is a real member, okay? One is real member, another one is real member, another one is a imaginary member. Okay, these two we call them as what? Members of structures. These two are called as members of structure. Okay, definition is completed. Complex definition is completed. Within the braces, we have to provide what are the members under the data type name, which is complex, which is of a structure. Okay, now see how to take this main part. I am declaring main. So in this, now tell me, what is the size of the C1, C2, C3? Very simple. Sum of the size of all the members is nothing but the size of the variables. Whenever I created C1, C2, C3, then C1 has some space which is of how many bytes? This is 4 bytes. This is also 4 bytes. So total how many bytes? 8 bytes of space will be created under C1. Same way under C2 8 bytes. Same way under C3 also 8 bytes. So this is whenever I declare, this is what? Variable declaration. This is what? Variable declaration. So how to read this? C1 is a variable which is of complex type. C3 is a variable, C2 is a variable of complex type. Same way C3 is a variable which is of a complex type. Whenever I declare these variables of complex type, the structure will be copied. All the space of members will be created here. Space of the members will be created here like this. Okay, after this, all these are something like output statements, the printf, enter C1 value. Now how to scan the value? I want to store 4.7. In the previous example we saw 4.7. How to provide this 4.7 into this location? This location is nothing but what? Real part of C1. Therefore scanf, this real part is of what type? Float type. Therefore %f comma ampersand C1 of real part. And if you want, therefore I will take 4 points. With the help of scanf it is possible. Same way, if I want to provide 7, then what I have to do? That is of integer type. Therefore %d comma ampersand of C1 of imaginary part. You see, this is an imaginary part of whose value? C1's value. Therefore I am taking this. If you clear this, it is the same as, this is same as like previous C1. Okay, same if I want to take C2 value also. C2, when I want to read 5 comma 4, I want to read 5 plus 4i. Okay, of course you cannot read this, but this is an illustration. We just assume that the numbers will be of 4i, but actually we won't provide i, we just provide 5 comma 4. Okay, this 5 has to be settled here. How to do that? 5 is a real part of C2. Therefore C2 dot real, which is of course ampersand C2 dot real, which is of what type? Float type. Therefore %f ampersand of C2 dot real. Okay, but you don't write real because real has 3 locations. This is real part, this is a real part, this is a real part. Where I have to store this value? Therefore I have to specify which variable it is. I am interested to store the value in C2 variable. Therefore like this. Same way C2 dot imaginary. Now the question, how to calculate? This is calculation part. Calculation is very simple, just like how we explained here. these sum of these two terms, okay, these two terms, real parts of C1 plus C2 will lead to what? C3. Same way, sum of imaginary parts leads to sum of result of imaginary. Just I read this. C1 dot real plus C2 dot real will be stored in a C3 dot real value, real position, something like this. Same way, imaginary part of the previous two terms will be stored in a C3. Now I want to display the result. What is the result actually? The result is 4.7 plus 5, 9.7 plus 11i. Okay, if I want to store like this, okay, I want to print the result like 9.7 plus I11, or it is also possible, right? 9.7 plus 11i. The same structure I have to follow. See, sum of two complex numbers I have to write, and the first is a float, right? Therefore percentage f. Second one I want to print plus, therefore I am writing plus. And I want to print this 11. 11 is nothing but what? Imaginary part, which is of what type? Integer type. So these are format specifiers, okay, and this should be ended by I, right? I, okay, and I have to specify this percentage f belongs to whom? Result, right? C3 dot real value, C3 dot real. Same way, this belongs to what? Percentage d belongs to what? C3 dot imaginary. That's what I did exactly. Sum of the complex numbers is nothing but what? Percentage f plus I percentage d. It doesn't matter, because if I follow this structure, it will be here. If I followed percentage d followed by I means this will be printed. This is how we can apply structures concept on different data elements.